Okay, picking up where we left off, we're looking at this core concept, this layered concept on page 439. So the core's responsibility is basically just to pass traffic, and that's it. It doesn't have any other responsibility. The distribution part is getting the traffic to the regions, to the buildings. You know, for example, I have a building over here and a building over here. The distribution is responsible for just getting it to there. And then lastly, of course, the outside ring, the access layer, where you actually have the LAN technology. You could say this is the LAN portion, this is the WAN portion. You could make that distinction. I will tell you that the whole idea of this is, you know, for redundancy. For example, I have a switch here that is connected to these other guys, and so if any of this faulted, I could still talk between the individual, the four buildings or campuses or whatever these things are called. So it's all about redundancy, and clearly we're talking about big business and big distances in order to make this a profitable kind of a thing. Zooming out a little bit more, now here you have that exact same thing. So here I have a campus with buildings, and over here I have another campus with buildings, and then these little smaller guys. By the way, this is considered a collapsed core. If I collapse the core and the distribution together, which is typically the way it works if you're not a big organization, you would have a collapsed core, then have the distribution. Then have the access. So this is, you know, several college campuses that are physically located far away using WAN technology to connect. So I'm not going to zoom back any further, but anyway, that's how this thing works. Okay, so once again, the shopping list. Let's say, for example, you were hired to go in and wire a building and put everything in. So you're going to be responsible not just for the networking components, you know, the switches and the routers and all that. You're probably going to be responsible for the nuts and bolts. And I do mean literal nuts and bolts. We're talking about, you know, building a 19-inch rack to put these things in, bolting the 19-inch rack to the floor, getting an uninterrupted power supply and putting it in the rack, and doing all the mechanics of it, of building the physical structure where these networking components are going to be, you know, physically placed. So it's a lot of work. You can't just open the boxes like on Christmas Day and plug them all in and have it work. There's an awful lot of setting up and reading the manuals and scratching your head. It's big business. Okay, so yes, you may have to buy a 19-inch rack. And I would never consider that a networking component, but they do, because unless you want these things sitting on the floor, you're going to have to do something. Cool. The next thing you talk about on page 440 is the maintenance, because, okay, their definition, pretty good one. Action is to keep the network in serviceable condition. Well, okay, what that really means is this stuff don't run by itself. You know, unlike your home environment where maybe the first day you set some passwords and, you know, changed the admin password on your router and hooked up the wireless, and then you probably haven't touched it since. This stuff takes an awful lot of effort. You need some network professionals to do this for a living, to go out and, you know, make sure there aren't any security updates and, you know, firmware updates and all that. So yes, just like you have software updates on your machine, well, trust me, routers have software updates in just the exact same way. You know, you just like going to Microsoft and getting an update and having it run, same scenario, you know, for these routers and firewalls, identical. You have to always go back to the manufacturer and pull these things down and try them out. Okay, so the next thing I talk about is the tools that you use to scan the network to see if everything's working. Okay, there's a way you can scan for hardware. On page 441, they talk about this remote monitoring stuff. There's one called Simple Network Monitoring Protocol, SNMP. By the way, a lot of people, you know, it's very close to Simple Mail Transfer Protocol, just a couple letters and change. And so a lot of people see that and they read it wrong. But anyway, Simple Network Monitoring Protocol, been around for a really, really long time. And this is designed so that it's a standard protocol that I can have, and all vendors support it, So if I'm sitting over here, I could ask, hey, Mr. Router, how are you doing? Are you okay? And the router says, oh, I don't know. I'm about a 50% saturation. You go, okay. So you go talk to the other router. Hey, Mr. Router, how are you doing? And he says, oh my God, I'm completely overwhelmed. I've got 10 times more traffic than I was designed for, and I'm dropping packets like crazy. So this is a way to have you talk to the hardware. You could set up alarms so that whenever a router starts dropping a lot of packets, it sends a note or an email or text message or something to you that says something's going on, you need to go look at it. Okay. There's a thing, when you go out and buy a switch, one of these little components here. Well, let me zoom out a little bit here. I want to buy one of these guys. Well, these guys come in two different flavors. One of them is called a managed switch, and one's called an unmanaged switch. And the unmanaged ones are like the ones you buy for your house. They don't have that SNMP management piece built in, because basically you're talking about a small computer in there, with memory and hard drive and all the rest, that can respond to health requests, look at the device, and send a response back. I mean, it's a little small computer in there. So yes, a managed switch is going to cost more than an unmanaged switch. Okay, cool. There's these management consoles you can bring up and get to view all your devices. We had one where it showed all the network devices, and they were like color-coded. This switch is in green, and this was in yellow, and this one over here is in red. And so you could just glance at the screen and go, ooh, something's going on over in that building. And so you go, dig down a little deeper. So they have a little diagram here of how this thing works. So I have some sort of a device, and these devices are running these little agents. They're managed devices, so they have these little things running. And so here's all these switches, and I can even have this go down to an individual computer and ask the computer how it's doing. Yes, Windows machines do indeed support SNMP requests. It's slightly different. You may have to tweak the security a wee bit. But so I have some management station up here that says this hard drive over here on this machine's in bad shape, or this switch is overwhelmed, or this router is acting up, or this one's forwarding packets that it should not be forwarding. So you're sitting back here just on some management station watching the network, watching things turn from green to yellow, going, whoops. Okay, so they try to make it kind of sort of simple. Alarms and remote notification. One of the key features of this kind of thing is, in the old days they would like send you you had to have a pager, right? And they would, but now of course it's just text messages and emails and things of that nature. Maybe even a phone call that basically says, oops, I'm in alarm condition, come see. I will tell you that the SNMP is the generic version, and almost all vendors add on to it because, the SNMP was, first of all, it's ancient, and there's like categories of this stuff that you can work with, but almost all the vendors go well beyond that. And so, like, if you go get a Cisco-based router, switch, hub, firewall that's managed, it's going to be able to do a heck of a lot more because it's talking to its own devices. Because this way, I'm sitting over here talking to 3 different vendor switches. The amount of information I'm going to get is relatively small compared to if they were all the same vendor. Makes sense? Okay. So there's another way you can look at this. And one way of looking at this is, instead of looking at the hardware perspective, let's look at the software. Let's scan the network and see what software is going on. All the information about the machine. So I'm going to do a little demo here that shows you how you can do this. Hang on a second. Okay, so here's a piece of software that's specifically designed. I'm gonna do a run as administrator here. Just give me a second. So what this guy is going to do, he is going to gather all sorts of information about this one PC. Now, admittedly, it could be configured to scan the entire network and draw the same information on every machine in the network. So here we go. I'm going to run this. It only takes a few seconds, so just sit back and watch. So it's collecting data about this machine. And you can see by the little progress bar, when it gets to the event logs, it kind of slows down a little bit. Okay, so here's a lot of information about this machine. This is the basic about the information. Here's all the accounts that exist on this machine. Here's all the people that are in the administrator group. Here's all of the, I'm going to switch the view here to this. Here's all of the components that are installed. Here's the CPU information, devices. Here's everything that shows up in the device manager. Wouldn't it be kind of cool if you had a device that was not working somewhere on some machine, somewhere in your network? Wouldn't it be kind of cool if you had an admin console that lit up and said, hey, that machine over there in sales, one of its devices is not working. And so you show up on their doorstep and say, I understand that your machine's having a little bit of trouble. And they look startled. They go, how did you know? Well, I've got monitoring software that does this for me. Here's hard drives and drive letters. How about how much we set this up with queries, and so we would run a query to find out who's running out of hard drive space. And so whoever was, we'd order more hard drives that are larger sizes, and we go out and swap them out with somebody who perhaps doesn't need such a large one. All sorts of information, how you're connected to the internet, and map drive letters, and how much memory you have, and on and on and on and on and on. QFE is all the patches. So I know every single patch your machine has had since the beginning of time. The date it was installed, what it is, all that information. So I could run a query that said, how many machines out there don't have this security patch? Okay, this is incredibly valuable information, because if you're a network administrator, you do not want to have to physically wander around, the 300 or 400 or 1,000 machines that you have and check individually which machine doesn't have a patch. That is not going to work. You'd have to hire a staff of 100 people to do that. Using these tools, you get to do it for nothing. Okay, so that is what remote monitoring software in the state of the machines is all about. Almost all of the corporate versions of like the antivirus, anti-malware stuff, if you go get Symatech Enterprise Protection, antivirus package for your company, it has like a management console just like that, and it can scan all the machines just like that, and it has color codes just like that shows you, here's all the machines that are okay, and here's a machine over here that's still got something. Maybe its virus signature is not quite right, or maybe it's got something in quarantine right this very minute, and you want to go talk to them about it. Yeah, cool stuff. All right. So that's about maintenance. Maintenance is, the whole point of this section in maintenance is that unless you proactively are listening to the network, listening to the PCs, and listening for things like antiviruses out of date, or hard drives that are failing, or all these other things, if you're not out there actively doing that, then your network is not going to work. Okay, so the next thing they talk about is kind of weird. They kind of change subject because they talk about standards. And so the standards committees have been out there for quite some time. We've had some talks about this in the past. One of the reasons why the World Wide Web works so well is that the standards are incredibly small, very simple, and very easy for other people to implement. So it made it to the point where the web is almost universal. Standards based to ensure interoperability. The next time a new browser comes out, it's typically not going to wreck the existing web pages. Typically, right? You would hope not. So, because that's the way things work, you'd think, well, the standards process is so important that when a new threat comes up, they're going to act really quick on it and save us from this evil. No, that's not exactly how that works. But let's finish this off in the next 15 minutes.